Thank you. So continuing with the Department of Energy, we'll next have Henry Kelly, who's in the Office of Energy Efficiency and Renewable Energy.
First thing is to see whether I can find my talk. All right. Well, thank you for having me. I'm the wonderful opportunity, and I always do what Ed Lazowska tells me to do, so I'm here. But what I want to do is spend a few minutes talking about what it is that our organization does, and then talk about some of the intersections between IT and our goals. Our work is, of course, divided up into very specific programs targeted on specific areas of energy end use and on renewable energy generation work. So you can see we have programs in buildings, in transportation, in advanced industries. We have programs on fuel cells, solar, geothermal, wind, and hydro, and biomass. So each one of these, of course, is laboring, in most cases, to drive up the efficiency of processes and to lower the cost. But what I'm going to do is, instead of trying to go through this, the pieces, talk about at least three big systems level issues that we've been wrestling with, and trying to understand how the pieces fit together. And that was going to draw very heavily on IT. Now, in transportation, several things are happening. One is that we're going from a transportation system very heavily dominated by single passenger cars powered by gasoline into what's likely to be a menagerie of different kinds of vehicles with different kinds of energy sources. So you're going to have obviously heavy electrification. We've made a very major investment in battery-powered cars, plug-in hybrids, standard hybrids, even hydraulic-powered hybrids. You're probably going to end up with a change in the way people use these vehicles. Driving patterns are going to change. Behaviors are going to change. But the other thing that's happening, of course, is you suddenly have this information network that is imposed on top of this system. So, and I believe you had a talk earlier about the way that vehicles can communicate with each other and with roads. So there's a lot of natural sources of information. All of these congestion predictors are part of it. We're trying to understand how we can take these two very big changes and marry them in a way that makes the entire system work better. And we're of course trying to figure out things like, if you're going to put electric charging stations, where do you put them? How do people find them? How do you get people to a mass transit site? Apparently one of the biggest problems is just getting people that are 3 miles away from a site to the site and not have a parking lot that said, so it takes you 3 weeks to walk across. So there's a fascinating series of system issues here. The department, of course, is not in charge of intelligent transportation, but we would benefit enormously from it, and we're trying to figure out what our best value added is. The second system level issue is buildings. Buildings as an integrated system is a very large new theme, and in fact we're about to announce a hub, hopefully with very high level representation from the federal government. I have my fingers crossed. But the idea of this is that the intelligence of buildings and the way the systems operate together is at least as important as the efficiency of the individual components. And this relies in part on very inexpensive communication and sensors, but it also requires marrying the equipment and the way people behave. And so the focus of this hub, which is led by Penn State and has a very large number of other partners, is going to be on the old Philadelphia Naval Yard, so we're able to experiment with the entire Navy Yard. But again, the focus is, how do you come up with building design tools that are accurate, that are rooted in real data, and the design tools are only useful if the people who are designing buildings actually want to use them, and where the architects and engineers can basically have a dialogue using this, so you can do a lot of what ifs, and you say, well, that looks really ugly, but if I shifted it slightly, it's going to provide the amenity without the energy use. But the interface with the people who are in the design community is crucial. Right now, most of these things are, the energy models are built and used by physicists who enjoy entering pages of numbers, and this is just not the way buildings are designed. In addition to building the new, designing new buildings, these systems also are have to be designed for users, and they must, ideally they're intelligent enough to adapt the energy systems in the building to the actual usage patterns of the building. They should also be able to find out if something has gone wrong. Apparently, a large source of errors is that something like 20% of the sensors in buildings apparently are incorrectly installed or not hooked up at all. So if something is going wrong, you need to have a theory about what went wrong and ask people to fix it. If a piece of equipment is about to fail or is out of spec, you should find out about it. And there are places like Walmart that have actually gone to the point where they have a system that can tell which freezer door in which compartment of which store is left open, and can send people out to fix it. So the operational aspects of these buildings is also a major IT challenge. The third system, of course, is the grid itself. And this is actually affected by the way the transportation system works and the building systems work. Right now, something like 72% of all electricity goes into buildings, so the way buildings operate is a very, very big deal. You're probably going to be charging vehicles in or close to buildings, and that's going to, if anything, just increase the building-related loads. So you now have a problem here with a new pattern of variable demand on the electric system. Plus, if you're going to have renewable devices, you're going to have unpredictable inputs from solar or wind and other technologies. And you're going to, the question is, how do you meet the remaining amount of the remaining integrated building utility load? Well, you need to have a smart system for doing the dispatch, but you have several other interesting tools. One is, of course, if you do have inexpensive energy storage, that gives you a lot of design space. But demand management is also crucial. And one of the things you can do if you have a smart building is to say, well, we have a forecast that shows that it's going to be really hot at 4 o'clock this afternoon. You start chilling your building early, knowing that you can then use the mass of the building as a buffer, allowing you to shed a lot of load during the crucial period. Again, you need to make this work, though. You have to marry the design and behavior systems in the buildings with the design of the integrated grid, which is a largely unsolved problem. One unpleasant factoid, by the way, is on the debate between how much should be automated and how much should be user-controlled. Lawrence Berkeley Lab did a survey of programmable thermostats in the Bay Area, and they found that 20% of them had the clock set to the wrong time, and 40% had the thermostat, all the smart features overridden, and the house was at a fixed temperature permanently. So this is a pretty sad commentary on the actual behaviors of people trying to use these systems. So a final system that has been fascinating to us is that we are trying, of course, to revolutionize the energy economy of the United States, and at the same time build a lot of new jobs and new employment opportunities around them. One of the problems is a huge mismatch between the training that's available in the workforce and the needs. We're trying to trying to fix this by building a very simple platform for building and using certification, the training. And this has been, one of the problems with all of these things is they're very expensive to build, and then they're obsolete immediately, and you have to go back to the same contractor over and over again. Our proposal here, and we've actually implemented this, is we're just using off-the-shelf open source solutions to all the problems, including the 3D immersive environment, which is probably going to be embedded in the next release of HTML. So it's the standard visualization tool, and this it's going into wide use right now. People are developing all kinds of very interesting software on this. The adaptability of this is crucial because if you're training somebody to retrofit a house, this is one immediate problem. We took the system to New Orleans, and it said go to the basement and look at the furnace, and they said we don't even bury people in the ground here. What's the basement? So they were able to quickly come up with their own version of this. It also allows you to do performance-based testing and change the definition of certification. In any event, we are at least. I told Ed I was going to be talking more about what we don't know than what we do know, but there are a lot of powerful things that advances in IT computation and human machine interfaces, human device interfaces contribute to energy, and they're not at the periphery, they're right at the center. So I'm looking forward to working with this community and helping us figure out how we exploit this opportunity. And thank you.